Are you struggling to understand object-oriented programming? I'm going to break it down for you with simple examples that even a beginner can follow. By the end of this video, you'll have a clear grasp of the fundamentals like classes, objects, inheritance, and more. Let's dive in. Object-oriented programming, or OOP, is a programming paradigm that organizes code into reusable blueprints called classes and creates objects from those classes. Think of it like designing a house. The class is the blueprint, and the objects are the houses built using that blueprint. OP is widely used in languages like Python, Java, C++, and more. Why? Because it makes programs more modular, easier to maintain, and scalable. Encapsulation is one of the fundamental principles of object-oriented programming. It focuses on bundling data, attributes, and the methods that operate on that data into a single unit, a class. By doing this, we can control access to the inner workings of the class and protect the integrity of the data. Why use encapsulation? Data protection. It hides internal details, ensuring that the object's internal state is not directly accessible or modifiable from outside. Code reusability. Encapsulation makes your code modular and reusable since each class has well-defined responsibilities. Improved maintainability. Encapsulation ensures that if you change the internal workings of a class, the rest of the code remains unaffected. Why use make and model are hidden within the class, and we interact with them using the start engine method. Encapsulation is not just about bundling data, it's about ensuring that data is used responsibly and consistently. By using access control, getters, and setters, we can create robust and maintainable code. Encapsulation is the foundation of secure and scalable applications. Inheritance is a powerful feature in object-oriented programming that allows one class, called the child class, to inherit attributes and methods from another class, called the parent class. This helps in code reuse and establishing a logical hierarchy in your programs. Why use inheritance? Code reusability. Avoid rewriting the same code by inheriting common functionality. Modularity. Organize related classes into a hierarchy that reflects real-world relationships. Extensibility. Easily add new features or behaviors by extending existing classes. Notice how the dog class inherits from animal and overrides the speak method. This is the power of inheritance. Advantages of inheritance. Code reusability. Write once, use in multiple places. Logical hierarchy. Reflect real-world relationships in your code. Scalability. Add new features without altering existing code. Inheritance is one of the most versatile tools in OOP. It allows you to create reusable, extendable, and well-organized code. Mastering inheritance will enable you to model complex systems effectively, whether you're building games, applications, or frameworks. Polymorphism is a key principle of object-oriented programming that allows objects of different classes to be treated as objects of a common superclass. In simple terms, polymorphism allows one interface to be used for a general class of actions, while the specific action is determined by the type of the object. Why use polymorphism? Flexibility. You can write more general and reusable code. Extensibility. New classes can be introduced without changing existing code. Code simplification. Polymorphism helps avoid large conditional statements and repetitive code. Here, the speak method adapts depending on the type of object. That's polymorphism in action. Polymorphism allows you to write flexible and reusable code, making it a cornerstone of object-oriented programming. Whether it's overriding methods, operator overloading, or working with abstract classes, polymorphism enables your code to adapt dynamically to the objects it handles. Mastering this concept will elevate your programming skills to the next level. Abstraction is one of the four fundamental principles of object-oriented programming. It is the concept of hiding the internal details of a process and showing only the relevant information to the user. By focusing on what an object does rather than how it does it, abstraction simplifies complex systems and enhances code readability and usability. Why use abstraction? Simplification makes complex systems easier to understand by focusing only on essential features. Modularity helps organize code into logical components. Security restricts access to certain details, protecting sensitive data. Ease of maintenance hides internal implementation, allowing you to modify the code without affecting other parts of the application. Here, shape is an abstract class that enforces the implementation of the area method in any subclass. This is abstraction in practice. Advantages of abstraction. Hides complexity. Users and developers only see what they need to interact with. Promotes code. Reuse. Abstract-based classes and interfaces can be reused across multiple projects. Enhances maintainability. Changes to internal implementation don't affect external functionality. Improves design consistency. Enforces uniform behavior across different implementations. Although abstraction and encapsulation are related, they serve different purposes. Abstraction focuses on what an object does, hiding the details of how it does it. Encapsulation focuses on restricting direct access to an object's data, ensuring that it's used properly. Abstraction is an essential principle that allows you to focus on the high-level design of your application while leaving the details for later. Whether it's abstract classes, interfaces, or properties, abstraction enables scalable and maintainable code. Mastering abstraction will empower you to design systems that are as elegant as they are powerful. So, how does this apply to the real world? OP is everywhere. For example, a banking system can use classes for accounts, transactions, and customers. A game can use classes for players, enemies, and weapons. Even web applications like shopping carts use OOP principles. Let's quickly recap what we've learned. Encapsulation bundles data and methods. Inheritance creates relationships between classes. Polymorphism allows methods to adapt. Abstraction hides complexity. With these basics, you're ready to dive deeper into OOP and build amazing things. Thanks for watching. If this video helped you understand the basics of OOP, give it a thumbs up and subscribe for more programming tutorials. Don't forget to check the description for example code and resources. See you next time.